So applications for quantum computing are commonly talked about. I just wanted to highlight a few here. Really, the takeaway here is that this is the most innovative step change in computing since the transistor. And you can look at these qubits as like the innovation of a new transistor. The applications range from financial modeling to chemistry. It's pretty widely understood in the field that chemistry is likely to hold the largest basket of killer apps, those kind of million and billion dollar applications, because it's very natural for a quantum computer to do quantum simulation. That's what it is. And that quantum simulation is at the core of chemistry. And so if you're designing new molecules for drug applications, you're inventing new proteins for drug discovery and treatments of rare diseases, that protein folding is very complex, and you cannot model that classically today without making a lot of approximations and assumptions, and rate equations for how is a chemical process going to go. And that ties into climate modeling here at the top, where commonly mentioned applications, the Haber-Bosch process. How can you make a process that we use today that takes a lot of pressure and a lot of high temperature, which means a lot of energy, and make it much more efficient, like nature does it? Cryptography and cybersecurity is an area that Aliro has a lot of experience in. There's both the threat of a quantum computer at breaking RSA encryption, but then there's the benefit in the layered protection of secure quantum communication through either direct secure communication or the key distribution as well. AI and machine learning are really converging with quantum today. There's a lot of talk. A lot of the companies are incorporating that into their roadmaps, which is appropriate. And one of the reasons is that the human brain is a neural net. So we have these neurons, they are connected, they have weights, and that's artificial intelligence, obviously, and if you can model it. And machine learning allows you to then set those weights and train an algorithm and then read it out as well. And so I think that the AI developments are going to help us design and run a quantum computer. Doing error correction is immensely complex, time-consuming, data-intensive as well. And so using AI to design those algorithms to actually optimize the weights, et cetera, is going to be beneficial. And then modeling the human brain as a neural net. I think there's a lot of excitement in the AI sphere with quantum as well. And then finally, there's a lot of applications in optimization. Every company has optimization problems. This is going to likely require a large-scale fault-tolerant quantum computer, given the scale of the problems, but there's expectations that we're going to see great benefits. And then financial modeling, financial vertical of banks and hedge funds is one of the largest investors in quantum computing. You see a lot of the prototypes coming out from them, and they're looking at better financial models, better risk assessments, predicting these black swan events, these rare events, like a bankruptcy or a recession, are very attractive as an application as well. So the takeaway is there's immense application potential. We don't yet have that killer app. We will likely need a large-scale fault-tolerant quantum computer to realize those, but we're in this age where we're exploring applications with a quantum computer that is difficult to simulate. So it's kind of broken free, and it's doing things that are difficult to simulate.